Hello and welcome to this video on np.polyfit. I'll be going over how to create a quadratic line of best fit, as well as a little bit of the maths behind it. To start off, make sure you have all the necessary libraries imported. I just used this cell at the start of all my Python documents. It has all the necessary libraries you need for first year. You don't necessarily need to use every single one of these libraries in all of your Python documents, but it makes sure you have none missing. I'm going to need data points first. So I will create my own. You will usually be reading a CSV using pandas, which you'll have learned about in Python 4. If you don't remember that, go back and watch that video. Y equals 1, 2, 4, 8, 16, and 32. This will mean I have a nice curve in my data points. Now I want to create an array. Arrays are useful for NumPy. NumPy can use arrays to create graphs and create lines of best fit. If you want to learn more about NumPy arrays, you will learn about them in Python 5.2. So please go and check that video out if you do not remember anything about arrays. So I'll create a variable array, numpy.array list zip x and y. The zip function is very useful. It assigns each x value a corresponding y value. So in this case, it'd be 1 to 1, 2 to 2, 3 to 4, so on and so forth. Now we can use the numpy.polyfit function. So we'll create a variable, call it grade integer, and equals numpy.polyfit. And there are 3 parameters in the polyfit function. The first one is our x values, which we have named x conveniently. Second one is y. And the third one is the degree of the equation of the line of best fit. And what degree means is it is the highest power of an x term in the equation. So a quadratic takes the form x squared plus x plus c. And because we have an x squared term in there, the degree of a quadratic is 2. And as we're creating a quadratic line of best fit, I'll put 2 in this last parameter. If you had a linear line of best fit, which is just a straight line through your data points, the equation of a linear line of best fit would be x plus c. And x is just x to the power of 1. So the degree in that equation is just 1. So if you had a linear line of best fit, you would just put in 1 here where I put 2. What numpy.polyfit does is it prints 3 values in this case. So the format of a quadratic equation is ax squared plus bx plus c. And what numpy.polyfit does is it prints the a, the b, and the c value. So the a is the value before the x squared, the b is the value before the x, and the c is the value at the end. In a linear line, numpy.polyfit would only print 2 values because a linear line takes the format ax plus b. So numpy.polyfit would only print a and b. So I'm going to write out a, b, c equals grade integer. Now I'm going to print these values to show you what they are. So the a value is the coefficient of the x squared term. That just means it's the number before the x squared term. The b is the coefficient of the x term, and the c is the value at the end, the plus c. So to print these, I'm going to use an f string. What an f string allows us to do is it allows us to put variables and functions inside a string, which is exactly what we want to do in this situation. So I will go f a equals, and then to put our variable in, to put our a value in, we start a curly bracket and go a, and to round it to 2 decimal places, we put in a colon and then put dot to f. Python likes to round to a lot of decimal places. Isn't very helpful for us. We want to round down to a reasonable number. So here I'm just going to round down to 2. And finish off the string. And then I want to do that for the b and the c value. So I'm just going to copy and paste this. C, Control V, and then add in b and c. There you are. So this means that the value before the x squared term is going to be 1.77. Value before the x term is going to be negative 6.63, and the value at the end of the equation is going to be 6.90. So the equation of our line of best fit is going to be 1.77x squared subtract 6.63x plus 6.9. Now we want to get the x and the y values for our line of best fit. To get our x values, I'm going to create a new variable, line x, which will just be the x values of our line of best fit. I'm going to make that equal to linspace, which has been covered in more detail in the video on numpy.linspace. But here, we're going to set up the three parameters. First parameter is just the first x value, which is up here, which is this 1. And to access this array up here, just go x0. And then the last value of the x array up here, which is the 6 value. So to access that, I go x5. And then the number of points. To avoid any jags and to make the curve nice and smooth, put in 100 data points, which is high enough, but also not too high to use up too much processing power. And then to create the y values in our line of best fit, we use the equation of the line of best fit itself, which is a function. So we'll take each and every x value that has been evenly spaced between these two parameters, and then it will send it to a y value. So each x value will have a corresponding y value. And the equation, the line of best fit, takes the form a multiplied by line x, as these are our new x values, squared, plus b multiplied by our x values, plus c. If this was a linear line of best fit, you would just have a multiplied by x plus b, or whatever value you've assigned to your x values. Here I've used line x, but you can use whatever you want. So I'm going to print the x values and the y values to show you what they look like. So print line x and print line y. Enter. So as you can see, this first group of values are our x values. As you can see, they're all evenly spaced from our first number here, 1 to 6, evenly spaced, and they've got 100 values. And we'll also have 100 y values, but each x value will have been put through this equation to obtain its corresponding y value. And that's it for this first video on np.polyfit. I'll see you in the next one where we'll be going into how to graph these values and how to create a legend as well.